Hello and welcome to 5th grade Unit 5, Division with Whole Numbers and Decimals. Please have your note sheet ready, have a notebook ready to take some extra notes, and rewatch the video if you need to find out some more information of new concepts. Here we go. The first one we're going to talk about is all the different parts of a division problem. The first number, or the biggest number, is the dividend. The dividend is going to be found inside our division problem. The next number is our divisor. That is what we're dividing by. That is our outside number. The answer to a division problem is called a quotient. And if we have anything left over after we divide, that's called the remainder. You might remember from 4th grade math the McDonald's model of does McDonald's sell cheeseburgers? This helps remind us the process of division. Hopefully by now you have this process pretty well solidified. If not, it'd be a good idea to go back and practice your basic long division methods. Here are some of the examples. We have the digit by digit method is probably the one that most people are using. We have either the new way, which is utilizing boxes, or the old traditional method of doing the long division. I still would encourage you to do the newer method. It helps with organization. So if we were to solve this problem, we would have 7 on the outside. We would draw a big box. We have 3 digits on the inside, so we would split it into 3. We put those digits in that top right corner of each box, and then we simply start dividing. How many 7s go into 3? 0. We divided, we now multiply. 7 times 0 is 0. We subtract. We bring our amount over after we check that 3 is smaller than 7, and it is. Next, we divide in our middle one. We get 5. 7 times 5 is 35. We subtract that out. We get 4. 4 is smaller than 7, so we bring it next door. 7 goes into 42 6 times. We multiply, we get 42. We subtract, we get 0, so we have no remainders. So our answer is 56. All right, we're going to utilize that method in order to divide with decimals. When we divide with decimals and there's a decimal only in the dividend, the inside number, life is pretty easy. We don't have to do too much. So we're going to set up our problem with the 3 on the outside. We're going to make our box. We are going to put our whole numbers. We're going to make a skinny box where our decimal goes, and then any numbers after that. So the 1, the 2, the decimal, and then the 9. And then we start dividing as normal. The only difference is this decimal is just going to travel straight up in its problem. 3 goes into 1 0 times. We'll subtract that out. We bring that next door. 3 goes into 12 4 times. We subtract that out. We get 0. Now if this was an amount that we subtracted and still had, we would just carry it across that decimal and put it into the next box. 3 goes into 9 3 times. We multiply, we subtract, we get 0 remaining. Now, when it comes to decimals, we cannot have a remainder. We would keep dividing. We could keep adding boxes and putting zeros here if we had a number down here that we needed to carry over. Because a number like 12.9 and we keep adding zeros after it means the exact same thing as 12.9. But in this case, we did not need to do that, so our answer just became 4.3. Now, if you had to continue on, most of the time your problems would say round to the nearest tenth. So then you only would have to go to the hundredths place value to round your answer. Moving on to a decimal in the dividend and in the divisor. This is where it causes us a little more work. We don't want to divide by decimal numbers. That's going to put a lot more work on us. So if we move our decimal to the end of the problem, this is the same as fractions. What we did to the top, we did to the bottom. So now what we do to the outside, we also have to do to the inside. So if we moved our decimal one spot to the right on the outside, we have to move it one spot to the right on the inside also. So our decimals go into different spots. So we now have the problem of 35, and that's a good number to divide by. We can do that. Divided by, we have 4 digits, and it's 1, 5, 7. Now notice that decimal is after the 7, so I'm going to put it in after that 7 and bring it straight up, just like we did in the last problem, and then put the 5, because we had to move the decimal in both parts of our problem. Now we can divide as we did before. 35 goes into 1 0 times. We bring the 1 next door. 35 goes into 15 0 times. So we get 15. 35 goes into 157 4 times. 4 times 35 is 140. And you might have to do some of your multiplication to get those problems. We get 17 remainder. We bring that next door. And 35 goes into 175 5 times, and that is 175. So when we subtract, we get 0, so our problem is done. Our answer would be 4.5. We don't need to write those 2 zeros on the front end because they don't hold the place of any number. So we would just get rid of those. But for our problem, we should show them so that we can get all of our values in the right place. Next is working on powers of 10. If we are dividing by powers of 10, we're going to make the number smaller. The exponent tells us how many places to move the decimal or to move the digits. We would move a decimal to the left, which means we move the digits to the right in order to make our number smaller. So in this case, we have a 1, so we're going to move the decimal one spot to make our digits smaller. So this is going to be 0.78. In this text, in this curriculum, they like to say move the digits. So we are going to be moving the digits this time 2 spots. And since we moved the decimal 2 spots to the left, we moved the digits 2 spots to the right. And we would get an answer of 0.078. So again, whichever way you move your decimal, the digits move the opposite direction. So we're going to move our decimal 3 spots to the left, and we fill empty holes in with zeros. So we're going to get an answer of 0.0078. When we're dividing by powers of 10. It's very simple because all we have to do is move the digits or move the decimal. In this unit, you're going to have to remember dabs. What does that remainder mean? Drop it. You don't need it. This is used when you're asking for full or whole amounts. A, add one more. Add one more to the quotient is used when dealing with people or if we need to buy enough of something. B the answer. Use only the remainder as your answer. We use this when they're asking for how much is left, remaining, or left out, anything of that sort. Last or last page could be. And then S, share it. Write the remainder over the divisor. This would be in fraction form. We might use this in money or measurements. Measurements would use the fraction form. Money would use the decimal form. Compatible numbers are used when we're trying to see if our answer makes sense. So a compatible number would be rounding our numbers to make an easy division problem. So 28 is not something I can count by 28s very easily. But that is closest to 30. I can count by 30s because I can count by 3s. And then I'm going to divide that by, I want a compatible inside number. Well, what's divisible by a 3? That would be a 9. So I'm going to change this to 900. So then we can do our division problem. 30 can't go into the 9, but 30 can go into the 90 3 times with 0 left over, so then we can just pull that 0 up. So if we were to divide 868 divided by 28, we should get an answer that's close to 30. All right, now it's your turn to try. Try these problems. Pause the video. Resume when you're ready to check the answers. Make sure to watch the entire video of the answers to see how to solve each problem. All right, let's look at problem number 1. We are going to divide our 2,412 by 3. Before we do that, we can find out if our answer is reasonable by using compatible numbers. We don't need to change the 3. It's already a single digit. It's easy to work by. But instead of 2,412, I would want to round that number to 2,400 because 3 goes into 24 8 even times, and then we had the 2 zeros that we'd put on. So our answer should be about 800. So then we divide it out, and when we divide it out, we get the answer of 804. So yes, our answer is reasonable because it was close to our compatible number answer, or what would be called our estimation in division. Number 2. If Ryan buys pencils for $10.20, not including tax, each pencil is 85 cents. How many pencils does Ryan buy? Well, we're going to move the decimal to the end of our 85 cents, which means we have to move our decimal in the $10.20. So we end up with a problem of 1,020 divided by 85. 85 goes into 1,020 12 even times. So Ryan bought 12 pencils. For problem 3, again, we're going to look at those exponents. They tell us how many times to move the decimal to the left or the digits to the right. So the first one, we moved it 1 spot, which makes it 5.07. The next one 2 spots, 0.507, and the last one 3 spots, 0.0507. For number 4, Marcus bought a skateboard. That skateboard is 3 times how much the helmet cost. So we're going to do a division problem here. We're going to take our 97 and 44 cents and leave it alone because we're dividing by 3, and 3 is already in a nice place. We don't need to move any decimals. So we're not going to move the decimal in our problem either. It would just go straight up. So when we divide that out, we get $32.48. The next one, if we solve with any method, we do not want to divide by 0.05. So we're going to move that, and we move it 2 spots to get it to the end of the problem, which means we need to move the inside 2 spots. Notice we had to add a 0 at the end of this. You must add this 0. If you do not, you will end up with a wrong answer. You would end up with 73, and that would be too small. We then divide our 3,650 by 5, and we get 730. Rewatch the video if you need to. Try some of the skill plan in IXL or any of the lesson checks in the Math Activity Center. Good luck!